Welcome to College Algebra. Let's get started in our work with functions for the semester with linear equations. So this should be a review of some work you've done previously in working with linear equations in two variables. So the goal or the objectives of this section is to use the slope to graph a linear equation in two variables, find the slope of a line given 2 points, write a linear equation in two variables, and use the slope and linear equations in two variables to model and solve real-life problems. So let's get to some basic information, some formulas that we need to know to complete the work in this section. So let's recall the slope formula. Remember, if you're trying to find the slope between 2 points, and let's just suppose we had a point x1, y1 and a point x2, y2, whatever those values are, to find the slope, we just subtract the y values, y2 minus y1 in the numerator, and subtract the x values, x2 minus x1, and that's placed in the denominator. So we'll practice finding the slope of a line, or the slope between 2 points. We'll also use the slope-intercept form for an equation of a line. And that equation looks like y equal mx plus b, where m is the slope and b is the y-intercept. We'll also work with the point-slope form for the equation of a line, and that is going to be used when we're given a point and we're given the slope. And so all we have to do is plug in the x1, y1 in these two positions, plug the slope in that position, and we can find the equation of a line. And it's called point-slope because you need a point and a slope to use this equation. Another thing we need to recall is that if we have a vertical line, the equation of a vertical line is always x equal to a constant, and a vertical line has no slope. A horizontal line always has an equation y equal to a constant, and a horizontal line has zero slope. So there's a difference between no slope and zero slope. Sometimes we say a vertical line has a slope that's undefined. Because remember, the slope is what is happening as you move left to right along a line. And as I move left to right on this horizontal line, I'm not rising, I'm not falling, there's no change, so the slope is zero. The thing about a vertical line is you cannot move left or right on it. That's why its slope is undefined. Now your slope can be positive, negative, or zero, or undefined. If you have a rising line, your slope is positive. If you have a falling line, your slope is negative. A horizontal line has zero slope, and a vertical line has undefined slope. So let's find the slope between the points in these few examples. So let's find the slope of the line in the following. So you can clearly see that you're given 2 points in example A. So let's use the slope formula. M is equal to y2 minus y1 over x2 minus x1. At any time, you can pause the video, work it on your own, and then start the video again to see if you did it correctly. To put my values in, this is the point, we'll call him x1, y1, and this is the point x2, y2. So let's put those values in our formula. So I have a -2 minus a -4. Those are my y2 minus y1. And x2 minus x1 will be 4 minus 6. Just a note here. Watch out, we have a double negative right there. So the first number, y2, was a -2. The formula says to subtract, and then the other value was a -4. So just be careful with that. All right, so it looks like I get -2 minus a -4, which is -2 plus 4 over 4 minus 6. which gives me a 2 over a negative 2, so I end up with a negative 1 slope. So m is equal to negative 1. Work on the next two. You might want to pause it, work them out, and then come back and check your answers. So setting this one up, I would have 5 minus a negative 4, and then 3 minus 3. Well, 5 minus a negative 4 will be 5 plus 4, which is 9, and 3 minus 3 is 0. We have a problem. Division by 0 is undefined. So this slope is undefined. So we'd end up with a vertical line. Undefined slope tells me I have a vertical line. Next guy, let's set him up. Negative 5 minus a negative 5 over negative 8 minus 4. Well, the numerator comes up to be 0, and the denominator is a negative 12. 0 in the numerator is okay. That's just equal to 0. Therefore, the slope is 0, and when my slope is 0, that tells me I have a horizontal line. Okay, let's look at this last one. You can use the formula, y2 minus y1, x2 minus x1, because we have a point and another point. So let's set it up. So I would have negative 1 minus 4 over 1 minus 0. These are my y2, my y1. So negative 1 minus 4. There's my x2, x1. So I'd have 1 minus 0. So let's see what I get. Negative 5 over 1, so the slope would be negative 5. And notice that's a falling line, and the slope is negative. Falling lines always have negative slope. So let's graph a line that's in this slope-intercept form. This is in the form y equal mx plus b. M is my slope, and it happens to be a negative 3/5. B is my y-intercept, which in this case is 7. So a very easy way to graph this is to go to the y-intercept first, go to your y-axis, find the number 7, and mark a point. There's your y-intercept. Then from that point, we can use the slope to find another point on this line. If you recall, the slope is the same thing as the rise over the run. And in this case, the rise is negative 3, and the run is 5. So starting at the y-intercept, the rise tells me to go down 3. So I'm going to go down 3 units, 1, 2, 3. And the run tells me to go across 5. And since that's a positive 5, I'm going to run to the right. 1, 2, 3, 4, 5. And that gives me another point, stopping right there on my line. And all I need to do is connect my dots. So easy way to graph a line. We can use the rise over run and graph that line with the y-intercept. There's some other lines we'd like to graph. So what I want you to do is think about these guys, because it's either a vertical or a horizontal line. Remember, x equal to a number, what we said earlier? It's a vertical line. So all I do is draw a vertical line at the number 6. Easy to graph, right there at 6. Y equal to a number is a horizontal line. So I need to go to the y-axis, find negative 2, which is here, and draw a horizontal line. And as you're going to find out as we continue our work in this class, f of x is just another name for y. So f of x equal 4 is the same thing as y equal 4, which means it's a horizontal line. So let's find 4, and let's draw that horizontal line. So x equal to a number, vertical line, y equal to a number, horizontal line, another horizontal line. For these two, we want to put it in slope-intercept form, which is y equal mx plus b. And then once it's in that form, we're going to go ahead and graph it. So that means we need to solve this equation for y, solve this equation for y. So I will transfer the 5 over to that side by adding 5. I'll transfer the 3x to the other side by subtracting 3x, and I end up with y equal negative 3x minus 5. Let's take the other one and let's solve it for y. So transfer the 15 on the other side by subtracting it, transfer the 6x on the other side by subtracting it, so I get minus 3y is equal to minus 6x minus 15. Subtract the 6x, subtract the 15. Now, why is it standing alone yet? I've got to divide every one of the terms on the left and the right by the negative 3. So negative 3 over negative 3 is 1, so I have 1y. Negative 6 over negative 3 is a 2, so it's a positive 2x. And negative 15 over negative 3 is a positive 5. When they're in the y equal mx plus b form, you can very easily graph them with the slope and the y-intercept. So the y-intercept here is negative 5. I'll mark a point. The slope is negative 3, which is the same thing as negative 3 over 1. So my rise is negative 3 and my run is 1. So I am going to go down 3 for the rise and across 1 for the run, and it puts me right there at the point 1, negative 8. So did you catch my mistake? Right here, for the 3x, I have to subtract 3x to get him, transfer him on the other side. And for this guy, I have to add 5 on the other side to transfer the 5. So my equation was wrong. I knew something wasn't right when I plotted that second point. So I found my mistake. So let's fix this graph. The y-intercept is not at negative 5. It's up here at positive 5. Now I'm still going to do the rise over run, but I have to go from my y-intercept, which is now correct. So I'm going to go down 3 and over 1, which puts me right there at the point 1, 2. Connect those dots, and you have graphed that line. Do the same thing for the other one. Let me check my work. Negative 6x, negative 15, divide by negative 3, and I get 6 divided by 3 is 2, blah, blah, blah. Check my work. Okay, we're good. So we have another y-intercept at 5, and the slope is 2, and that's like a 2 over 1, so I'm going to rise up 2 and over 1. Puts me at another point on my graph, and I can now connect those dots. I'll stop this video here and pick up with the next video for the rest of this information.